Welcome dear students. In this module we are going to talk about one of the mostly used data structures that are provided in C, which are called arrays. So as part of this module we are going to discuss and know as programmers why and when we should use arrays and how to declare and initialize one-dimensional arrays, and we will take an example which is nothing but adding two one-dimensional arrays, which is nothing but the example would take two vectors. A vector could be a simple row matrix or a column matrix. So we know how to add two column matrices or two row matrices and get a third row matrix or column matrix, which is a summation of the corresponding elements. That we will take it as an example and see in a C program how to declare arrays, how to use them and process them, and so that we are able to use arrays in other problems also. And finally, one-dimensional arrays can also be used with functions. We can send them as arguments to a function. So you can send a whole array to a function and the function can process that. That also we are going to see as part of this module. Now let us try to understand what is meant by an array. In the real world, an array is defined again as an orderly arrangement of a large collection of things. Things could be anything. For example, real world arrays. One of the examples is cars in a parking lot. When you look at cars which are nicely parked in a parking lot, when you see them, the row of cars are there, one after the other. Same way, cycles in a cycle stand, if they are just nicely parked, you will know that there is one cycle and beside that another cycle, like that. You can see a row of bicycles. They are nicely arranged. Same way, you can rooms in a hotel, one after the other, you have several rooms. So all these things, an array in English means the orderly arrangement of several things in rows and columns. That is the general real world meaning. Same thing when it comes to C. Arrays in C are nothing but, just like we have one after the other cars, we have one after the other integers. Array of integers means it will contain several integers placed one after the other, just like cars are placed one after the other. Array of floats, what is that? Again you have several floating point numbers placed one after the other nicely in a row. Same way, array of characters, one character placed after the other nicely in a row. So that kind of an arrangement. So an array is simply an arrangement of your individual numbers together in an orderly fashion. Now let us look at how to declare and also initialize one-dimensional arrays. We know when you declare anything like this, memory is set aside so that one single integer value can be stored in this variable a. For example, I can store now a is equal to 10, and if I store again a is equal to 20, the 10 will be gone. Only the currently stored value will be there in a. So we say that at any point of time, this variable a can hold only one integer value. On the other hand, if I declare, let us say like this, notice the square brackets. In C we use various kinds of brackets. We use braces, we use normal parentheses, we use angle brackets, so on and so forth. So whenever you see a square brackets in C, it has a special meaning. It stands for an array. So when you declare like this, it is different from here. You can store only one value, but here this is an array of 5 integers. Like you have an arrangement, you have sufficient place side by side so that you can store 5 integers side by side. Just like you can park 5 cars one after the other. Now you can store 5 integers one after the other. So assuming again each integer takes 2 bytes, obviously this declaration will allocate memory sufficient for 5 integers, which is 5 into 2, 10 bytes of memory. This can be visualized like this. this declaration results in something like this. 10 bytes, of course, each box is 2 bytes here. Totally 10 bytes. You can see that there are 5 boxes, meaning you can store 5 integers at a time. Now the question is, how are these individual elements referred to? Earlier there is only a single name A, but now we have 5 integers. And now each one of these elements are referred to with an index. The first element always starts with 0 in C. The one which you see within the square brackets is the index. So A is the name of the array, in square brackets the index. The first one is 0th element, then you see in square brackets 1. This element is referred to as A square brackets 2. The final one is referred to as A square brackets 4. This is what we should notice. The size is 5, but the indexes vary from 0 to 4. But the size is 5. There are 5 elements, but the names are A0, A1, A2, A3 and A4. So it is always, the range is from 0 to 1 less than the size, because we start from 0, not from 1. So you have 5 elements set aside. Each are individual, completely different elements altogether. They share only the name, but they are referred to, because they have to differentiate it, because they all have the same name A. We use the indices to separate them. So if you want to refer to this element, I simply say this would put the value here. And if I want to refer to this element, I simply say this would put 20 here. I can say now both on the right hand side, left hand side and the right hand side. What will this happen? The value at A4 will be assigned to 0. That is 20 gets copied into 20. So this is how we use. So they are just like individual integers only, but they are members, or they are part of an array. Only the notational convenience is there. With one single stroke, you can assign for any number of arrays. If you 500 elements, sufficient memory is allocated. You can just go on. 5,000, 50,000. The limit is only set by the computer that you have. The physical memory that is available in the computer, that is the only limit. C does not set any limits. So with the single stroke, you can see that 50,000 integers, the memory sufficient for that can be allocated like this. So that is the beauty of an array. With one single stroke, a large amount of memory can be allocated at a time, and they can be very easily processed also, as you are going to see. So let us go back to these 5 elements only. We can also declare and initialize an array at the same time, in the same statement. This is how we do it. Declaring, and at the same time we can just put equal to. We use the braces here, and we give a list of values that you want to be put into this array. They could be simply 10, 20, 30, 40 and 50, let us say. As you can very easily guess, the value 10 is going to be assigned to the first element of the array, which is A of 0. So this 10 will get into here. Next value will get into the next element, which is A of 1. Likewise, that is called initialization. Sometimes the number could be less than this. For example, I have given only 3 values. The question comes, what will happen in another case? I give only 3 values, but there are 5 elements. What will happen at that time? Very simply, the first values will always get into the first 3 elements, but the remaining elements for which I have not given any values will be automatically assigned 0 values. So when you initialize partially, the remaining elements will be given 0 values. But what you have to very carefully remember is, if I don't initialize anything, if I simply declare an array of size 5, in that case all the 5 elements will have garbage values, undefined values on which you cannot depend upon. So all uninitialized variables like this, they will have garbage values, but partially initialized, the rest will be initialized to zeros. Another way of initializing a one-dimensional array is we can leave out the size. As you can see here, the size is missing here. I have initialized with 3 values. In such case, an array of only size 3 will be created, and it will go 10, 20 and 30. But this size can be left out only when you are initializing. What I mean by that is, we can never declare something like this. This is wrong. The value can be left out only when you are initializing, because see, the memory allocation in arrays, the size must be specified. It must be a constant integer or an expression which must be able to be evaluated at compile time. That's what you have to very carefully remember. Just like you declare integers, you can also declare arrays of floating point values, arrays of characters, arrays of structures, which you are going to see later, arrays of unions, so on and so forth. That declares an array called B, which can store a maximum of 20 elements of type float. So in each one of the elements, a floating point value can be stored. Character array with the name can store a maximum of 30 elements, each of type char. The maximum of 30. You can store less also. Here also it is the maximum size of 20. You can even just use part of it, depending on the problem. But a maximum of 20, no more. So this sets the maximum size. That much space is allocated. Within that you can use only part of the space. Rest of the thing can go waste. But more than that, it's not possible. In order to understand how to declare and use one-dimensional arrays, let us take a very simple problem from your matrix algebra. Assume that there are 2 column vectors, as we call them. You all know, if I want to add these 2, and if I want to get a resultant matrix, how do we carry this out? Very simply, the corresponding elements will be added, that is 2 will be added to the value at the same position, which is 10. So you will get 12, 8, 10 and 12. 2 plus 10, 3 plus 5, 4 plus 6, 9 plus 3. By position, we just add that and put that into the third. Now let us try to write the same thing as a C program which accomplishes the same task. Given any 2 column vectors, what should the program do? It should be able to add them and find the result and put that into the third resultant matrix. And of course the condition is that both of them must be of the same size. So this is a mathematics problem, simple problem. So same thing, now we have to write a C program in order to carry this out. Now having defined the problem, you have to see how you are going to store this column vector in our program. Same case with this, same case with this. You see that there are several values, not just one. There are 4, or it could be more also. Right now there are only 4 values here, 4 values here. For these kinds of cases, array is the best solution. For example, we can declare, because there are 4 values now, I can store this in an array of size 4. I can put the values in the individual elements of the array. I can call this as array A. I can have another array again of size 4. Into that I can put these values. First element will be 10, next element will be 5, next element will be 6, next element will be 3. Read them into that array. Now we can just add these and put them into a third array, again of the same size, 2 plus 10. Once these are added, the resultant array will be put into a third array, which you can call it as C. Now if you can guess what could be the actual processing statement which will add the corresponding statement, you can see that if this is array A and this is array B, how do we add? 0th element, because this is A of 0, this is B of 0. Can't we say now, and this is C. So all we need to write is something like CF0 is nothing but 0th element from the A matrix plus 0th element from the B matrix. Similarly, if I want to get the first element, same. From A matrix we pick up the element with index 1 plus from the B array you pick up the one with so on and so forth. Of course, finally it will be 3. Manually doing, that's how we will have to do it. But now in the program, what would be the steps? Very simply, first we need to allocate sufficient memory so that we can store all our numbers. That is 2 and the third array for the result. 2 arrays you declare integer arrays, and first array you read these values. Into the second array we read these values. You have to type in the values. Then the arrays are ready, values are available. Then this statement, as you see, has to be repeated for 4 times so that corresponding elements are added and put into the third resultant array. So these steps now I am going to write as a simple complete C program, and I hope that will enable you to understand how to declare arrays, how to put values into them, and how to process them. And mind you, one-dimensional arrays are very nicely processed by using for loops, which you are going to see in the sample example. Now let us look at the partially written program here. We will finish it as we go along. Normal statements only. I want you to notice the first line here. Depending on the problem, we need to declare our arrays or variables. Now we know what we are going to solve. We had that problem in our head, that we need to add 2 vectors of size 4. So I have declared here 3 arrays. You can see here. This is one array of size 4, A, an array called B, again of size 4, all are integer types, and a third array called C, also of size 4. Why 3? Because we know the problem already. We need to have 2 for storing the values, initial vectors. We need a third one to store the result. That's why we declared 3 arrays of integers. Then I declared I. You will understand why later, because I am using a for loop. Then you see that I am asking the user to input the values of the first matrix. Now at this line, what happens is the user will start typing the values of the first matrix. For example, the values are, let us assume that the values are 2, 3, 4 and 9. They are different values, not 2349. 2, 3, 4, 9 with spaces separating them. Now you see for loop has been used. There is scanf statement. This scanf statement will be executed how many times? Because it is attached to the for loop. The for loop, you can see it is starting from 0. Why it is starting from 0? Because we know that the array indices always start from 0. So whenever we write for loops which process array elements, more often than not we always start with 0, because the indices start from zeros. So I is equal to 0. Notice that I put less than 4 because with starting size is 4, indices start from 0, they will end with 3. So I less than 4, I plus plus, and this scanf statement will be repeated 4 times. But what is the difference in those 4 times? First time when scanf is executed, what is the value in I? I will be 0. That means this will look like address of A. So address of the 0th element. For example, if your A array is here, there are 4 elements which are referred to as AF0, AF1, this is AF2 and this is AF. So now when the first time scanf is executed, the value is going to get into address of AF0, which is nothing but this address of this element here. So 2 gets in here. Next time scanf executes, I would have become 1. So your 3 will get into here. Next 4 you have entered will get into, because when the scanf gets executed next time, I would have become 2. It will go into here. Finally 9 will come here. So you can see that with a simple for loop, even if the size had been 4000, just this code would have read 4000 values with simple one line. It's because it is repeated using the for loop. So you can see that array elements can be very easily manipulated using a for loop. For loops and arrays are very nicely matched. Actually for loops are designed as they say, specifically for to work with arrays. So this will read values into the first array with the same logic with which the first array has been read. The first matrix has been read into this array A. These lines here will read the values into the second array, which is named as B. This will also go through 4 times, and the first value 10 will get into B of 0, second value will get into B of 1, third value B of 2, fourth value B of 3 as the for loop iterates. So using a for loop very nicely, almost identical code, but the name has changed here. This is the second array, this is the first array. So with this code in the computer's memory, in this array A and array B, the values of our vectors are already stored. Now only the next step is simply to add the corresponding elements and put it into the third array C. That again we use a for loop, as you are going to see. This code, as you can see here, again I is starting from 0, it will stop at 3 less than 4, and one statement is here, only one, which gets repeated 4 times. Every time what will it do? When I is equal to 0, it will add A of 0 to B of 0, put it into C of 0. That is the value here. For example, the values would have been 10, 5, 6 and 9. A of 0 plus B of 0, put it into C of 0. So if you have a third matrix here, the first time this gets executed, it picks up 2, it picks up 10 because it's A of 0, B of 0, added with the plus operator, put it into C of 0. So 2 plus 10 goes into, next time it iterates 1 and 1, A of 1, B of 1, put it into C of 1. So A of 1, B of 1, 3, 5, added 8, put it into 4, 6, 10. Whatever, if the values are 9 and 9, this would be. So this for loop simply iterates for 4 times, and every time you are accessing the individual elements of the array and the job is getting done. Now you can simply write one more for loop to actually print these values. Just like this. Instead of scanf, you simply write printf without the ampersand here. Of course, you will be using the array C because I want to see the result which is there in the C array. I simply write one more for loop and iterate through the C array and just simply print the values. So the printing of the values in C can be done with another for loop. For I is equal to 0, I less than 4, same thing. Printf %d, the values in CFI. So it will print C0, C1, C2, C3. And this is the return statements, end of the main function. So this is a complete C program which tells us or exposes us to a real problem, taking 2 row matrices or column matrices, how to add them, because in order to store them we need arrays first of all in our program. So we need arrays whenever we need to have this kind of a situation. Large numbers, when we need to store them in the computer's memory, we go for arrays. And arrays can be very easily manipulated and processed using for loops. Now let us try to understand how arrays can be sent as arguments to a function. For that we will simply rewrite just the example we have seen, which we have used only one function main. In that we have written the entire code. The same thing now we will split up into 4 functions. One main function will be there anyway. In addition to that, we will have 3 more functions, very simple functions. One function's job is to read values into the array. Another function's job is to add the 2 matrices and put it into the third matrix. The third function's job would be simply to print the values. So now this is aimed at, this example is aimed at telling us how to actually send functions, send arrays as arguments to functions. As you can see here, I have written the prototypes of the 3 functions. First function, second function, third function. All the return types are void because the functions are not going to return anything. First function's name is read matrix. It is going to receive 2 arguments. One is first one, as you see, square brackets are there. So first one is an array. Second one is a normal integer variable. Second function, the name is add matrix. It has 1, 2, 3, 4 arguments. First 3 are arrays because because it is going to add, it needs to receive 3 matrices. In 2 of the matrices values will be there and those values will be added put it into the third matrix, and it also know the size of the matrix. So 4 arguments are there. And I have designed the third function as print matrix. It again receives 2 arguments, one array and one n. The values that it has to print will be contained in this array, and knowing how many elements are there, it is going to use a for loop to print the values. As simple as that. So now let us see the main function, in which again as usual I have declared 3 arrays. Notice now I made the size as 10. That is, each array can add a maximum of 10. But mind you, it can always be used to store anything less than 10, because I could be just using 4 as we have done in the previous example. So that is the flexibility. I have changed the program a little bit. Now instead of fixing it only for 4, we can use it for any value less than 10. So for that I declared it like that. I have n. Now I am asking for the number of elements. I will scan it. So in n, now you have the number of elements. For one problem it could be 5, another problem it could be 4, like before it could be 6, it could be 7, the size of the matrix could be 8, or so on and so forth. That number is contained in n, which is given as input to scanf. Once this is there, all main has to do is simply call the functions. Now what is the first job? We have to read the values into A, and then we have to read the values into B. So for that we have a function. So I simply call the function read matrix, capital M here. Let the case also match here. Now the big point is, what should be the arguments to this function read matrix? We have already declared our intentions. It requires 2 arguments. So what is it that you want to read first? I want to read values into array A. Just the name A, no square brackets, no int, nothing. Followed by what is the number or what is the size. Both are sent as argument to read matrix. We will write the body definition of the function later, but this is how you call the function. This is a function call. So this function call will read values into A, but I still have to read values into B. For that again I call the same function, but now I want values to be read into B, these many elements. That again has to match with, because the same function is now being called but with a different array. So with these 2 function calls, I have the 2 functions or 2 arrays ready. The values are there. Now what do we have to do? We have to call the add matrix. So I simply call add matrix, and it requires 1, 2, 3, 4 arguments. So I will send A, comma B, the empty matrix array C. I haven't put any values into that, comma, finally n. And by the time this function returns, the values would have been added. The result would have been available in matrix or array C. What is the final thing I would like to do? I would simply like to print the values that are there in C, which contains the result. For that I have another function available. What is that function? Print matrix. But how do we call that? Again it requires 2 arguments. What are they? Simply call print matrix. What are the arguments now? Which array you want to print? The name is C. How many elements are there? Simply that. That ends the main function. You can write return 0, put the brace here. That is the end of the main function. But of course the program is not complete. We need to define, write the bodies for these 3 functions, which I will try to do it here. This is the body of the first function, read matrix. As you see here, there are 2 formal arguments. The first one, it contains the type, name, and of course empty brackets, comma, int n. So when the function is called with read matrix A, comma n, the address of this matrix A would be sent here along with the value n, whatever it is. It could have been 4, it could have been 5, it could have been 6, depending on the matrix you are trying to add. That is received by this function. And what does this function do? It simply reads, as you can see, same statement which you have used earlier. Using the for loop, n number of values will be read into matrix A or array A. And again when it is called with B, once with A, next time with B, same function will get called, but this time even don't get confused with the name A here. This is just the name that is used in this particular function. If it is called with B, it will be the address of B only. The values will be read into B. This name and this name here A, they have no relation at all. The code of the second function is like this. Again, very simple. Just the addition part is there. But look at how the arguments are received. First argument, second argument, third argument, fourth argument. That must be matched here. You can see add matrix is called like this. Just the names A, B, C, N, they get copied here. So to this function, after this function call, all the three arrays are available. The value in N is also available. So it simply loops through using the for loop, and the corresponding elements are added. The values are put into C. And whatever this function does, the values are automatically reflected in the main function, because the arrays are sent in a different, they are not by value. Arrays are sent by a separate mechanism, using which the function, whatever values it puts into the array, are directly reflected in the main function also. The third function that we have used is a print matrix function. As you can see here, that is the name of the function. Two arguments are there. Look at the corresponding function call. We have sent C as an argument and N. So the C will get copied into A here. So the name in this function for C also, it will be used as A. So when you are using A here for with respect to the function call here, you are actually referring to C. So let us not get confused between the names here. It all depends on the function call. With C it is called, it will be C. If it is called with A, it will be A. If it is called with B, it will be B. Like that. So it's received here, again a very simple loop. It simply prints the values that are received from this function call. That is, in this particular case, the values contained in the C matrix will be displayed on the screen. So same program we have done before has been organized in different fashion. We have used functions here. Just you have to note the syntactical things, the prototypes, how to declare, how to make the function calls, and how to define the functions. So you have to look at the arguments, how they are defined here, how the function calls have been made, and how the prototypes have been defined. So if you can just get used to these things. So this is how normally a big program is decomposed into functions, so that the main function looks fairly simple, consists of several function calls, and the functions are defined elsewhere. Thank you.